So we're going to start off with 11.2a, Triangle Sum Theorem. And remember, this theorem just states that if we have three angles of a triangle, A, B, are we going to do this today? No, we're not. If we have three angles of a triangle, I guess we are. Okay, it's going to keep doing that, but just try your best to ignore it. It'll come back eventually. So if we have a triangle with angles A, B, and C, we can say that A plus B plus C is equal to 180 degrees every single time. This is the activity where we cut out that little triangle, ripped it in three pieces. You guys remember that? Yeah. Okay, good. So if we have an angle that's 50 degrees and an angle that's 70 degrees, what's my third angle going to be?
60.
Good. Let's set up the equation first. 50 plus 70 plus x is equal to 180, of course. There we go. Nope. Sorry, guys. Okay, there we go. So this is how we set our equation up. Now a lot of you are doing some like shortened versions, like just adding them together and subtracting them from 180. That's great, totally fine if that makes sense to you. But once we get to the problems with variables involved, we have to remember that this is our setup. We can add 50 and 70 together to give us, what is that, 120? 120 plus x equals 180. And we subtract 120 from both sides, giving us 60 degrees. Right? Number two, we've got a 90 degree angle and a 40 degree angle. So 90 plus 40 plus x is equal to 180. Gives us 130 plus x equals 180. And when we subtract that 130 from both sides, we get 50 degrees. Right? Now you probably did it a different way, but got the same answer. That is perfectly fine. But if we go down to number 4, we've got a little bit more complicated of a missing angle. My missing angle is not just question mark. Now it's 5x plus 12. But it doesn't matter. We're still going to add all three angles together and set them equal to 180 degrees, just like that. Here's my first angle, 42, my second angle, 71, and my third angle, 5x plus 12. Go ahead, Jordan. So we're going to combine like terms. We've got three like terms to combine, 12, 71, and 42. And what do we get when we add those three together? It's like 124? 125. 125, right? 5x plus 125 equals 180. We'll subtract 125 from both sides. And this is where I saw a couple people make a mistake. Simple subtraction error. 180 minus 125, what does that give us? 55 degrees. Double check and make sure you didn't get 65 degrees in your subtraction. We divide both sides by 5, and we're left with x is equal to 11. Now again, 11 degrees, 11 is not the degrees of the angle we found, it's just the value of the variable in that specific angle expression. I'm getting real sick of this, man. All right. Questions about triangle sum theorem before we move forward to the exterior angle theorem? Okay. See a few people not paying attention right now that are probably not making the best choice. Number 5, exterior angle theorem. Now this one, I kind of messed up on. We don't have notes in our notebook on this because we turned in the little yellow, like the pale yellow paper for the recorded lessons. But the exterior angle theorem is very simple. It states that our outside angle, the angle on the outside of our triangle, is equal to the sum of my two inside angles, which are 59 and 52. So all we have to do is add the inside angles together and set them equal to whatever the outside angle is. What is 59 plus 52? 111 degrees. There's our answer right there. All we had to do is add those two numbers together. Pretty easy, right? But number 6, we've got a little bit different of a setup. My outside angle is a number that we actually know. So when we set this up, we're not going to add 80 and 40 together. We're going to set it up like 80 is equal to 40 plus question mark. Yeah, sure. 40. And that's right. We're going to subtract 40 from both sides. And we end up with 40 degrees for our answer. Does that make a little bit of sense?
Yeah.
Okay. Now, when we introduce our expressions here, makes things a little bit more difficult, but we still set this up the same way. My outside angle is 95, so that's going to be alone on one side of the equal sign. And my interior angles, 8x plus 1 plus 4x minus 2, get added together on the other side. Now, what am I going to do first on the right-hand side of this equation? I've got to combine like terms, right? We can combine 8x and 4x to give us 12x. And we could combine 1 and negative 2 to get what? What's 1 minus 2? Negative 1. Make sure that you have a negative 1 in your equation. We'll add 1 to both sides to get rid of that 1, though, leaving us with 12x equals 96. So my x is equal to what? Should be 8. Exactly right. X is equal to 8. Now, what if I asked you, what's angle W? What's angle W equal to? How do you think we could find that out? Azalea, how can we find out what angle W is equal to? Multiply 8 by 4 and then subtract the 2. Where are you getting this 4 and this 2 from, Azalea? That's exactly right. Right here in our diagram at the W angle, right? Angle W is equal to 4x minus 2. So if we want to find what angle W is equal to, we just take away our x and plug in the x that we found, which was 8. 4 times 8 gives us 32. And 32 minus 2 gives us 30 degrees.
Wait, is that for number 8?
Yep, this is for number 7. So x is equal to 8, but if I were to ask you what is the measure of angle W, you'll just have to take that value of x and plug it in. Does that make sense? Whatever the expression is for W, take the x that we found, plug it right in, and solve. That is something you have to do tomorrow on the test. So please make sure you understand what I'm talking about right now. Number 8's a little confusing as well, so let's take a look. What's my exterior angle in number 8? 103, good. So my exterior angle is going to be all alone on one side of the equal sign. We're going to take our two inside angles, 7x minus 7. We're going to add them together, 6x minus 7 right there. Again, we're going to combine like terms. 7x plus 6x gives us 13x. Negative 7 minus 7 gives us negative 14. Still equal to 103. What are we going to do now? That's right, we're going to add 14 to both sides. Thank you, fellas. We get 117 equals 13x. I think that's right, right? Yeah, 117. And finally, we divide both sides by 13. Everyone knows this. What's 117 divided by 13? 9. That's right. I was joking. Not everybody knows this. But you could do long division to figure it out. You could also think of it like this. 13 times 10 would be 130. So if you do 130 minus 13, you get 117. Probably didn't make sense to most people, but it's okay. Hopefully it does. And what if we wanted to find the measure of angle B? How can I find the measure of angle B in this scenario? Well, what expression is equal to angle B? Seven x minus 7, right? That's my angle B. So I could do 7 times 9 minus 7. And that gives me what? 56, I think? 63 minus 7, 56 degrees for angle B. Again, that wasn't part of the problem on this worksheet, but it will be part of the test tomorrow. Definitely make sure you know how to plug in a value of x and simplify. Final questions on the front. We might as well go over real quick number 3 just because we have time and it's the only one we didn't do. But again, triangle sum theorem, we add all 3 angles together, set them equal to 180. So we get 100 plus 20x equals 180. We'll subtract 100 from both sides to give us 80, and divide both sides by 20 to get 4. Leave that there for a moment just in case you need to copy it down. And we'll flip it on over, take a look at the back, our parallel line situations. So taking a look at the back, we have to first identify the angle relationship shown. You will have to write the relationship on the test tomorrow. Okay? So you can't just know that they're equal, you have to know specifically what relationship we have. In number 9, what is the relationship that we have? Corresponding. We know this because they're on the same side of the transversal. They're both above the transversal or to the right of the transversal. But one angle's on the exterior and one angle's on the interior. That right there is the definition of corresponding angles. So what do we know about corresponding angles? Are they supplementary or are they congruent? Congruent. They're congruent, right? It's going to be one of the two. They're congruent. So all we need to do is set them equal to each other. Question mark is equal to 129 degrees. And that's my answer right there. Nothing to solve, nothing to simplify, no like terms to combine or anything like that. But what's my relationship in number 10? Vertical? Ooh, good guess. We can see that they're on the same side of the transversal and they're on the interior together. So these are going to be same side interior angles. Again, this is all on note sheet number, I forget what it is. I think it's 4. It might be 3. I think it's 3. So this is all in your notebook. Now, 50 degrees, that's an acute angle, right? But what does that question mark angle look like? Is that acute or obtuse right down here? Question mark angle. Looks obtuse, right? So if we have an acute angle and an obtuse angle, they can't be equal to each other. but they will be supplementary to each other. These ones are supplementary. So we can add them together. Question mark plus 50 equals 180. We'll subtract 50 from both sides, and we get 130 degrees. Anyone get 130 all on their own for number 10? Oh, good, a couple people. Great. Questions before we go to 11? All right. Number 11, what's the relationship here? Alternate exterior. They're both on the exterior of our parallel lines, but they're on opposite sides of the transversal. One's to the left of the transversal, one's to the right. Are these going to be supplementary or congruent? Congruent, right? Again, we just look at the drawing. 112, is that obtuse or acute? Obtuse. What about this question mark angle? Does that look like an obtuse angle or an acute angle? Obtuse. So if they're both obtuse angles, they are both going to be equal to each other. My answer is 112 degrees. The only time you need to add them up and set them equal to 180 is if it's the same side interior relationship. Number 12, a little bit more because we got a variable in there, but that's all right. Now, I noticed that they're both on the interior, and they're on alternate sides of the transversal. So what can we call this angle relationship? Alternate interior, exactly what it looks like. Alternate interior. Those are going to be congruent to each other. Congruent to each other. So we can set x plus 73 equal to 65. That's what congruent means, right? It means that they are the same exact angle measure. When we subtract 73 from both sides, what do we get? 65 minus 73, what does that get us? Negative 8. It's totally fine that we have a negative number because, again, we are not finding the angle measure. We're finding the missing variable, which in this case is negative 8. No degrees because we're just finding x. With the previous three, we did put degrees because we found the actual angle. Now we could plug negative 8 into this expression and find the missing angle, but we don't need to do that, right? Because what's the missing angle have to be? What's the degrees of my missing angle right here? Well, if it's congruent to a 65 degree angle, what's that measure got to be? 65. Right? 65 degrees. And if we plug negative 8 into this expression, negative 8 plus 73, we in fact do get 65 degrees. Let's move down to 13. What's the relationship here again? Corresponding, good. So those are congruent as well. 15x plus 10 is equal to 17x minus 6. What's the first thing that I want to do here? It doesn't look like there's any like terms to combine. So what should I do first? Any idea on what we want to do first? Yeah, Hannah. Perfect. Let's subtract 15x from both sides. I want to keep my variable term positive as much as I can. So that's a great way for me to get that positive 2x on the right. Leaving us with 10 equals 2x minus 6. We brought our variable term over to the right. So where are we going to bring our constant term? To the left by adding 6 to both sides.
Minus 6, right?
Well, it's already a minus 6, so we have to do the inverse operation, which would be plus 6 on both sides, yeah. 16x equals 2. Divide by 2. What's my x equal to? X is equal to 8, exactly. And finally, I'm running out of room here, but 14. What's my relationship here in 14? Well, it looks like they're on the same side, right? And they're on the interior, so these will be same side interior angles, which are actually supplementary. This is that rare occurrence where we have to add them together and set them equal to 180 degrees. Just like this. Boom. Let's get our like terms combined here. 109 plus 79 gives us 188. And x plus x gives us what, Max? 2x, exactly. Do you have a question? Sure. We get 2x, right? If there's 2 x's there, that's 2x. I want to subtract 188 from both sides. Get rid of that constant term, leaving us with 2x equals negative 8. And when we divide by 2, what are we left with? Negative 4. That's right. X is equal to negative 4. That is for number 14. Questions on my parallel lines? All right, number 15. Let's end it off with similar triangles. So these pairs of triangles are all similar. We got to set up a proportion and solve. So I'm going to do my color coordination here. My bottom side is 7 and 35. So let's just do 7 over 35. And my hypotenuse-ish, technically not a hypotenuse because it's not a right angle, but actually, I don't know if that's true. But whatever, the longest side that we have is 12 and x, so we'll do 12 over x. Now, 12 times 35, that's going to be a little bit difficult for us to do tomorrow without a calculator, right? But does anyone remember what shortcut we can take here to make this cross multiplication a little easier? Exactly, we're going to simplify. Well, there's only one fraction we can simplify. 7 over 35. So we can break that down. 7 times 1 over 7 times 5, just like that. We can cancel out the 7s, giving us 1 over 5 equals 12 over x. So that now my cross multiplication is a lot easier, and we save us the hassle of then also doing long division, because we're just left with x is equal to 60. I'm going to put units just so when we actually get to a word problem, I don't forget that I need to write feet. Number 16, my left sides are 10 and x. I'll do 10 over x. My right sides are 6 and 36. I'll do 6 over 36. Cross multiply. And we could simplify this one, but it won't be too hard not to. 6x equals 360. We divide by 6, and we get what? 60. How fun. Both answers to these similar triangles are 60. Anybody get 60 for both of those? Anybody second guess when they got 60 the second time? Like, oh, I must have done something wrong. Can't be 60 twice. Good, good.
Mr. Church, can we just do that?
Can we just do that? Yeah, that's fine, yeah. If you want to do it the shortcut way where we talked about how, 6 to get to 36 is times 6. So we take 10 and multiply by 6, and that gives us 60. Great catch on that. Yeah, no.
I bet.
Sure. No.